Okay, so Chapter 3, Section F, page 94 reading. Up until now, we have learned how to evaluate, we've learned how to evaluate y equals b to the n when n is, and the answer to this is when n is rational. Okay, so pretty much we've been using whole numbers, but sometimes we use things like 3/2, fractions, right? So rational just means it's a fraction with an integer on top and an integer on bottom. What are the possible values of b for the equation to be exponential? Well, b can be almost anything for this to be exponential. The only thing it can't be is it can't be 0, right? Because 0 to the whatever is always 0. That's going to be a line, or a really boring line. And the other thing that b can't be is 1, because if it's 1, then it's just going to always be 1 multiplied times itself, and that's also going to turn out to be a boring line, y equals 1. So b can be anything except for 0 and 1. So we'll just say, yes, b can be like any real number except 0 or 1, and then it will be exponential. So if it's anything negative, well, and then there's the case of negatives, which gives some really weird results with exponentials too. So we cannot be negative either. So change that. B is greater than 0, and also that b cannot be 1. Okay, so if these two things are satisfied, then the equation y equals b to the n is an exponential. Okay, to find y equals b to the n for any n, then we should look at graphs of exponential functions. Okay, so if we look at a graph, since a graph is continuous, it'll give us results or solutions for like any y or any x pretty much. So let's look at the case of 2 to the x. Okay, and we're going to calculate values of y for these y values of x. And some of these we can do by hand, right? 2 to the 0, of course, is always 1. 2 to the 1 is 2. 2 squared is 4. 2 to the third is 8. 2 to the negative 1 is 0.5. 2 to the negative 2 is 1/4, so it's 0.25. 2 to the negative 3 is 1 over 8, so that would be 0.125. 2 to the negative 10, that would be, negative 1 over 1024. I don't know what the decimal representation of that is. 2 to the negative 50, 2 to the, and we can just calculate it here, negative 50. Wow, that's tiny, huh? 8.88 times 8.88 times 10 to the negative 16. Okay. What value of y is the function approaching as x approaches negative infinity? Let's see. So if we see like when x is negative 10, it's already a pretty small number. It's about 0.001. X equals negative 50, it's already at 0.00015 zeros, and then you get to an 8. So x is obviously getting very, very close to 0. So let's say it's 0. What is the equation of the horizontal asymptote? Well, if y is approaching 0 as x approaches negative infinity, then the horizontal asymptote would be y equals 0. Because that would be the horizontal line that the function is approaching. And if we look here, I didn't show you this, but you see it on your paper. The points we've put here, such as 8, 4, 2, 1, 0.5, you can see them graphed here on this continuous graph of 2 to the x. So we've only shown you like obvious points that are integers, but this makes a smooth curve. So like any point in between these points is also a solution of 2 to the x. It's just not necessarily a whole number, not necessarily a rational number. Okay, so it says here, just think back to our Desmos investigation about the role of each of these numbers like C, K, and D, and we're going to use that later during our problem solving here. So now this is the same graph that we just saw above, but it's showing you how you can use the graph to find solutions that are not whole number exponents, for example. So we have a couple questions here. The value of 2 to the x, we're given value of x, for example. Let's find the value for 2 to the 1.8. You know, 2 squared is easy, 2 to the first is easy, but 2 to the 1.8, that's not so easy, right? So we're going to use this graph to figure that out. So we find out where 1.8 is on the x-axis, and then we just trace it up, and we intersect the graph, and then we go over to the y, and we see that it's about 3.5, right? So 3.5 is a solution for that. So we just found the solution for 2 to the 1.8 by using the smooth graph of y equals 2 to the x. Now the solution to the exponential equation for 2x equals b, remember during the last section, 3e, we talked about graphing as a way of solving this equation where you have an unknown exponent is equal to a number. So if we have like 2 to the x equals 5, then what we can do is we can find we can find 5 on the y-axis, and then we can see that it maps to 2.3 on the x-axis. So that we solve this with that. Okay. So now I'm just going to solve a few examples for you. Use the graph above to estimate the value of, and so let's see. We'll take this one, 2 to the negative square root of 2. Negative square root of 2, remember, is like negative 1.414, something like that. So we have 2 to the negative 1.414. And so if we look on the graph here, we have negative 1.414. That is the x value, right? So we would put it about there. What is the y value equal to? Well, it looks like it's about 0.4, maybe 0.35. So we could say it's 0.35 maybe. All right. Use the graph above to estimate the solution to, and they give us 2 here. Let's do 2 to the x equals 0.6. So we can take 0.6, it's about there. And that would be about equal to, let's see, maybe negative 0.7. Maybe. Okay. Use the graph of y equals 2 to the x to explain why 2 to the x equals 0 has no solutions. Let's see, 2 to the x equals 0. That's when y equals 0. That's right here. When is the exponential curve equal to 0? Well, actually, it never is because it's an asymptote. So it just approaches it and it never touches it. So you could write because y equals 0 is an asymptote. So 2 to the x never touches it. Something like that.